All right, you're welcome specially to Bengineer Construction Lecture Hub. This is a live streaming, and I decided to come up, to discuss a very important topic today. Okay, and the topic today is how to enhance the effectiveness or the performance of our axial members. All right. So, if you're just joining us, we are discussing how to enhance the performance of axial members in our buildings. All right. So, as you know, axial members basically are those structural elements in our buildings that takes care of axial loads. All right. Those concentrated loads are usually transferred from our beams to our columns. So it is the columns function to transfer that axial load to the foundation. All right, which will now lead to the eventual spread of that load. So if you're just joining us, we are discussing how to enhance the effectiveness of axial members. So like I said earlier, axial members are those vertical members we have in our buildings. Example is our columns. Now the function of our column is basically to transfer load, in form of axial load to the foundation. All right, so it's important for us to enhance the performance of our columns in this context. All right, we need to enhance it. Now, enhancing it will help in the effectiveness of that column to perform optimally. All right, so we are going to look at some of the ways that we can enhance our columns. Now, first, we have to look at the lateral ties. All right, as you know, the lateral ties are those smaller diameter of reinforcement that we normally use to get that column formation, okay, and also to enable us observe the spacings. All right, so it is the lateral tie, that is your links. We must have our links closely spaced, okay, closely spaced. Our links should be closely spaced. Then also we must maintain a 135 degrees bend. All right, because usually columns experiences buckling. Okay, they fail by buckling. Axial members in this context, like I said, the column, its failure mode is either by buckling or by crushing. All right, so I want you to take note of this. These are basically the two common ways our column fails. All right, so it's important that we give our column the required parameter, the required support, okay, and also the required cross-sectional area that will enhance effective transfer of this load. Now, like I said, our columns undergo buckling. Now, buckling is a function of the slenderness ratio, okay? By the time we look at the slenderness ratio, we look at the limiting slenderness ratio. These are the two that we have to look at, okay, to now judge our column, if that column is a short column or a biaxial column, as the case may be. All right, but that is in the design aspect. But we are just looking at how we can enhance the effectiveness of our column, or how to enhance the optimum performance of our column. So, like I said, we must ensure that our links are closely spaced. We must also ensure that we maintain 135 degrees bend, okay, for our columns. All right, then we'll also have to provide adequate cross-sectional area. All right, what I mean cross-sectional area, that is the geometrical size of that column, the length and the breadth of that column, not the depth, not the height in this context, the length and the breadth, that is the cross-sectional area of that column. We must enhance, or we must ensure that we have adequate cross-sectional area. Now, I want you to also understand something. When we are dealing with our beams, because our beams are usually supported by our columns. Now, the cross-sectional, the length of our beam, okay, the length of our beam also is kind of directly proportional to the depth of that beam. So what it means basically is that when you have your length of your span of your beam increased, it means that there will be a corresponding increase in the depth, for the depth of that beam. Now, when this increment in your beam, it also have effect on the column. All right, it also have effect on the column. So the column should also have adequate cross-sectional area to be able to first and foremost carry the weight of our slab and our beams, okay, and its own self-weight, because the column itself has its own weight. All right, so we have to also consider the weight of that column. So having a good cross-sectional area will help to limit the effect of buckling. All right, it will help to limit the effect of buckling in that column, which also is it also have a direct connection with our stirrup. Like I said before, we must maintain a closely spaced stirrup. Then we must also maintain a 135 degrees bend, and those bends, those hooks, ought to be alternated. What I mean alternated, it means that if you're putting one side of the hook at the right hand side, the next spaced lateral tie or links should be at the right hand side. Okay, so that is how you're going to be alternating it, because that will help to enhance the rigidity of that column. Because when our columns are loaded, usually there is a concentrated load, because we have uniaxial loaded column, we have biaxial loaded column. Now, I want you to understand that the load on our beams are usually divided into two along the span of that beam. Okay, so half of that load moves towards the nearest support, while the other half moves to the opposite support. Okay, now if you have a column that carries a T beam, that is a cross beam, it means that the four panels or the four partitions, the load will be divided, and half of both the four sides will move to that column. All right, now that column, now the load as it moves, it goes down. Then you have to also consider the weight of that column in your consideration. Okay, then that eventually gives the summation of the axial load that is being subjected, is being have that column subjected to. All right, so we must ensure that we maintain a good spacing. The hooks should be alternated. Then the bends for our hooks should be 135 degrees. The reason for this is that if normally you see people, oh, you're welcome. If you're just joining us, welcome to this live streaming. And our topic today, we are discussing on how to enhance the performance of our axial member. Okay, so if you're just joining us, you're welcome to this live session. All right, so like I said, we must maintain a 135 degrees bend. Now, the reason for this is that when you have a 135 degrees bend, it will help to enhance the rigidity of that column in terms of the reinforcement, because when the load comes on the column, it is the reinforcement that directs the load to the foundation. All right, it is the reinforcement, the main bars in your column, that helps to direct or give direction to the load the axial load to the foundation. Okay, so you must provide good links, okay, or lateral ties, or what we refer to as stirrup, all right, for our, for our column. But mind you, stirrups are for beams, okay, while columns, you term them lateral ties or links, as the case may be. Okay, so we must maintain a 135 degrees bend. We must also give a good spacing of these lateral ties. Now, one thing that the 135 degree bend of stirrup does is that it will help to prevent buckling, all right, because when the load comes on the column, there is always a reaction that tends to oppose that load. So that subjects that column to stress, to compressional stresses. Okay, it subjects that load to compressional stresses, and in most cases, buckling can play out. Okay, buckling effect can come in. All right, so for us now, we must maintain a 135 degree, like I said. So the 135 degree bend helps to prevent buckling. The reason is that if you do your 90 degrees bend, and when this column is loaded, you see that there are tendencies or possibilities of that hook to give way, okay, because they are at 90 degrees. But if it is at 135 degrees bend, you see that the concrete itself will also help to resist the effect of that hook opening, all right, because you know that the 135 degree, the hooks will be inside of the column, all right, inside of the perimeter of that lateral tie for our column, all right. So when we have that, it will help to enhance the performance of our column, all right. So as we go on, if there are questions, you can also drop them at the comment section. So like I said, we will have to provide a good cross-sectional area for our column. It is very, very important. Then we also have to provide a good clear distance. Now, the clear distance in this context is the distance between our stirrup, okay, half of our stirrup, to the outer surface of the concrete for that column. That is the clear distance. So we have clear distance around the perimeter of our column. So we must maintain uniformity in the clear distance, okay, because for example, if you have a square column, you see that if you're maintaining a concrete cover of 30 millimeters, it means that 30 millimeters should be provided around the perimeter of that column, all right. So that is what I mean by maintaining a good cross-sectional area, because when you provide cross-sectional area for our column, it will help to protect the reinforcement against heat, okay. It will also help to prevent that reinforcement from corrosion, because once our reinforcement gets corroded, it means that the tensile strength of that reinforcement will be depleted, okay, will be affected. So we try as much as possible to provide good cover, okay, for our columns, okay, so that it will help to also provide lateral support, to our column. So we must maintain a good clear distance for our columns, all right. Then I want us to also look at the grade of concrete that we use is also very important, all right. The grade of concrete we use is also very important. If you use a very low grade of concrete, you see that it will not have that compressional ability to be able to transmit or transfer the axial load. That is why you see most of our columns failing, All right, you see most of our columns collapsing. This is as a result of poor grade of concrete. So we must, for us to enhance the performance of our columns, we must provide or use good quality, of concrete, for our column. It is very, very important, because a lot of construction site tends to compromise, which is not good for that structure. So we must ensure that we do the needful, at every stage of our construction work, because whatever that you undermine in the course of construction have its own impact or negative implication on the overall functionality of that structure. So we must, put all of that into consideration. So as you know, column is very, very indispensable, when it comes to our building, because they are those components that carries the axial load. They are the vertically, positioned structural elements in our building. So we must give them a good quality concrete grade, for us to ensure that column can perform, optimally. All right. Then we also have to look at the area of the size of our main bars is also very important. Okay, when we design, we usually provide sizes of reinforcement, and that is a product of the area of steel, calculated. Because when we calculate our steel, okay, the area of steel during design, when we calculate the area of steel, we usually go to a table to provide area of steel, provided on the table, that is higher than the one that we have calculated. And that will now enable us to, get the number of reinforcement for that particular column. All right, depending on the area you have calculated. For example, if you calculated maybe 500 millimeter square, okay, definitely if you go to the table, you go for higher area, maybe 600, 700, as the case may be, millimeter square, area that is higher than the one you have calculated. That will now give you a good sizable reinforcement for that column. All right, so that will be also an avenue to give you guide on the number of rebars for that column. It could be 4, it could be 6, it could be 8, as the case may be. All right, depending on the code you adopted, either BS 81100, okay, or your hero code. Okay, so whichever provisions, whichever code that you are subscribing to, you now have to provide reinforcement area of steel provided. That will enable you, get the number of reinforcement as well as the diameter of reinforcement for that column. And usually we adopt 16 millimeter 16 millimeter diameter bar for our columns. We also adopt 20, as the case may be. All right, but the minimum is 12 mm. All right, and that 12 mm, you have to also look at the number, and basically for you to choose, or for you to get the diameter of that column, or the diameter of the main bars for that column, you must first and foremost design that column. It could be a uniaxially loaded column, it could be a biaxially loaded column, but you must design that column. You get the area of steel calculated, then that will now enable you go to the table to now provide area that is higher than the one you have calculated, and that will give you the clue on the selection of the main bars for that column. So it is important that we do all of this. That will enable us enhance the performance of our column. Now I want you to understand that once a column is defective, it is very, very difficult, to manage. All right. Although there are remedial actions that can be taken, which you can do your jacketing, retrofitting, and the rest. Okay, you can do all of that, to sustain or revive the stability of that column. But it's important that we do the needful from inception, so that it will enable us to, give that column the required strength, to be able to perform optimally. Now, I want you to also understand that our column should also possess a good internal resistance. All right, it should possess some level of internal resistance, because as the load comes downwards, there is always a reaction opposing that load. So what will sustain that column against this axial load and the reaction basically is the amount of the internal resistance that column possesses. That will help to guarantee the stability of that column. All right, so it's important that we look at this very, very critical when we are talking about construction. All right, and in our column, in our buildings, we have columns, different, it could be biaxial, it could be uniaxial. Now the span of our beam is also an important consideration in terms of the spacing of our column, because columns supports our beams. All right, so if we have the span of our beam, we have a corresponding spacing of our column. It will help to sustain that the structural or the flexural members in that building. All right, so the essence of this live streaming is for us to have this at the back of our mind when we are dealing with columns. Columns are very important components in our building, so we must ensure that we provide good cross-sectional area. We must also ensure that we provide closely spaced links, and we also have to maintain a 135 degrees bend, like I said earlier. Then we also have to provide good concrete cover, okay, which will enhance a better clear distance for that column. Because when you have a good cover to this reinforcement, it will help to regulate the effect of buckling, because columns are prone to buckling. All right, especially those slender columns, they are prone to buckling, while the short columns are prone to crushing. Those are the failure modes of our column. So basically, we must first and foremost identify our columns first. If that column is a uniaxially loaded column, if it's a biaxially loaded column, that will now enable us, carry out our design for that particular column. Now, in the course of the design, we are expected to, get the area, okay, because the steel has area. All right, so it is that, like I said earlier, it is the reinforcement that actually directs the load to the foundation. All right, the concrete, protects the reinforcement. Are you getting me? The concrete protects the reinforcement, just like the human anatomy. You see that your skin covers the bone structure in the human anatomy. Okay, that is how the concrete covers our reinforcement. It is the concrete that provides the needed cover for our reinforcement. So when you have a good, clear distance for that column, it will help to, protect the reinforcement. It will provide lateral support and also enhance rigidity of that column, and also in terms of the stiffening of the plastic hinge zone. All right, because that also is what we have to also consider in our column. because at that point, a lot of issues normally emanate. All right. So if we do the needful, we will help to curb all of those deficiencies that our columns are prone to have. All right. So we must try as much as possible to ensure that we don't have defective columns. When you have defective columns, you will see that the longevity of that structure will be hampered. All right. So basically, I decided to bring up this so we can have idea, okay, kind of an awakening lecture, if you can put it that way, for us to know some of those things to do that will enhance the performance of our column. So like I said, I've talked about so many factors, okay, which also talk about having a good quality concrete for our column, because concrete is good in compression. Concrete is good in compression, and columns are more of compression. They are exposed, or they are subjected mainly to compressional stresses. All right, they are subjected to compressional stresses, and also understand that columns deflect too. They undergo deformation. Okay, there are also lateral displacement in this context. So basically, what all the factors we've talked will help to limit or minimize, these defects, from occurring in our columns. Because once our columns, are defective, it is practically very difficult, to handle. All right, so we must ensure that we do the needful, because they carry the load from our slab and our beams and direct it to the foundation. All right, so we must ensure that there is proper pathway in the transfer of that load. So once there is a bridge, or once there is a limitation in the pathway, in the load transfer pathway, you see that column will be, will start failing. All right, it will start failing, because the way structures are interconnected. All right, structures are interconnected. You have your slabs, your beams, they are connected. Okay, slabs are hinged to the beams, while beams are hinged to the columns. Okay, so you see that every load on that slab and every load on the beam cumulatively are transferred to the column. So we must ensure that our columns are very effective, okay, in taking care of this load as they come. All right, because once the column cannot be able to sustain that axial load, you see that column will definitely fail. And once the column fails, automatically that structure will have issues. Okay, so practically what we are discussing this tonight is for us to understand those factors that we have to look at, that will enable us, enhance the performance of our column. So if you're just joining us, you're welcome to the Engineer Construction Lecture Hub. This is a live streaming, and we are discussing how to enhance the effectiveness of our column, or how to enhance the performance of our column. So like I said earlier, columns are very indispensable in our buildings because they carry axial load, while the beams and the slabs, they carry flexural, they transfer their loads via bending. That is their flexural members. So like I said before, the distribution pattern is that when the load on the slab is transferred to the beam, depending on the type of slab, if it's a one-way spanning slab or a two-way spanning slab, as the case may be, the direction of the load is towards the beam. Now, when the load from the slab gets to the beam, it is usually divided into two along the span of that beam. it is usually divided into two. Then half of that load moves towards the one side of the support, which is the column, while the other half moves towards the other side of the column. That is in a case where you have a beam supported at both ends, not a cantilever beam in this case. All right, so when this load moves towards the column, okay, you see that that load now will be converted to a point load, a concentrated load, which is an axial load. Now that axial load is expected to be directed to the foundation. All right, it's expected to be directed to the foundation. So once there are defects in that column, you will see that the transfer of that load will be hampered. And once a load is being trapped, in our column, you will see that that column will have problems. All right, it means that that column is bound to fail. So, but basically, the essence of this is for us to ensure that our column does their function effectively. And how will they do their function effectively is by one, providing lateral ties, that is our links, at close intervals. Then we must also maintain a 135 degrees bend for our hooks for the lateral ties. We must, there are persons that, is having the erroneous conception that mainly those hooks, 135 degrees hooks, are meant for, earthquake prone areas, in terms of resistance. As far as structures are concerned, it's important that we do the needful. Now, when you use a 90-degree bend for your lateral ties, there are tendency of the opening of that hooks, because they are at 90 degrees, okay? They will not be able to control the buckling effect that our columns might be subjected to. But when you have a 135 degrees bend as your hooks, you will see that it will help to provide the required rigidity and the internal resistance to resist that effect of buckling as a result of the magnitude of load that column is subjected to. So we must look at this aspect very critically. All right, so like I said, you maintain all of this. Also use a good grade of concrete, then also maintain a good cross-sectional area. Okay, you maintain good cross-sectional area of your column. Then you also provide good clear distance. That is the distance between the surface of the perimeter of your column and the reinforcement. You must maintain a good cross-sectional area. It is very, very important in terms of exposure condition and all of that. That will help to guide the reinforcement, okay, to be able to direct the load to the foundation. Because once the reinforcement is affected, you see that tensile stresses or tensile loads will be trapped. All right, although columns are mainly considered as compressional members. They are mainly considered as compressional members in our building. All right, because they are vertically positioned and they take axial load. Okay, so we must consider a good cross-sectional area, because that will also provide protection to the reinforcement and also guide the reinforcement, against the effect of buckling. All right, so these are some of the factors that we must put into consideration in order to enhance the performance of our columns. All right, so I want to thank every one of you that has been online all through. Thank you very much. I intend to come up live to discuss more, pressing construction, issues. All right, how to adopt good practices, to enhance the performance of our structure. All right, so I'm going to stop here for today. Thank you very much for your time, and do have a wonderful day. Bye.